Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm doing well, thank you. How are you?
Very good, very good. So today, what do you want to do?
Is it all right if we could continue from like our last lesson, just going through a couple of exam questions, see kind of the thinking behind it, and yeah,
So
that'll be
these
helpful.
exam questions which you have taken, are they real test papers or like what kind of test papers are they?
Yeah, they're real test papers. I think by our exam board at Excel. So yeah.
Okay, so specifically, can you tell us like which year it is? When you share with us, you can tell us which year it was, and then from there we'll continue. Okay,
I don't know about the year or anything because
I see.
teachers have kind of put that together randomly. So from every paper, they've taken out questions and just put it on a document. So they haven't really cited where from.
I see.
But
So that
yeah,
means these are the best test questions which you should be going through to prepare
right.
for the exam. That's the whole idea. Well, that's fair enough. So why don't you share with me? That's great.
Cool. Oh, that one. No, I do that. Okay.
Correct. So the circle question, I think we did last, right?
I don't think we did part two.
Oh,
And
I
that's the bit
see.
I definitely got stuck on.
Oh,
So
I see. I
yeah.
see. Okay. So we did part one. Okay.
Yes.
We'll start with part one itself for the benefit of those who take only look at our today's lesson, right? So
Okay.
can you please read question number 11?
Yeah. So the circle C1 has equation x squared plus y squared plus 18x minus 2y plus 30, which equals 0. The line L is tangent to C1 at the point P, which is minus 5, 7. Find an equation of L in the form of ax plus by plus c, which equals 0, where a, b, and c are integers to be found.
Correct. So the first part, can we quickly go through this? So idea is you can find the center of the circle, right? And what is the center of the circle, Emmy? Can you tell me?
Um,
Minus,
so the method I did was you take 18x, so 2g or something equals 18x. You get
right,
that as 9 and you switch the sign because it's the center is minus f minus g. And
correct,
then, yeah, you did the same for the y. So it's minus 9, 1.
correct, minus 9, 1. And for the benefit of all others, how do we get this? Is we adopt the method of completing the squares. Half of 18 is 9, right? So
Right.
I'll just rewrite this equation here as x squared plus y squared plus 18x minus 2y plus 30 equals to 0. We'll arrange the x terms, which are x squared plus 18x. And to this, we are going to add half of 18, which is 9 square of that, and subtract this. So that really doesn't change the equation, but helps us to factor, right? We get a perfect square using this. And the other part of this is plus y squared minus 2y. Half of minus 2, I mean 2 is 1. So we will add and subtract to this, plus 1 square and minus 1 square, right? So we'll do this. And we have plus 30. Let me take this, let me just write equals to minus 30 here. Is it okay? I'll just squeeze it
Yeah.
here. Okay, we'll write this as minus 30. Is it okay? Now, the terms, which are the first three terms here, they form a perfect square. And then we leave minus 9, and the other three also form the perfect square. And what we get here is x plus 9 whole square plus y minus 1 whole square. And we're left with minus 9 square, which is minus 81, and minus 1, which has not been used, equals to minus 30. Is that clear to you?
Yeah.
Right? So you'll take all those terms there. But we got the center of the circle. Do you see that? So the circle has been translated 9 units left and 1 unit down. That gives the center as minus 9, 1, correct? So the shortcut method, which Emmy is using, is very effective. We use the equation kind of like this, x squared plus y squared plus 2gx plus 2fx plus c equals to 0, where the center C is at minus g minus f. Is that clear to you?
Yeah.
So half of the coefficient of x with a negative sign and half of the coefficient of y, sorry, this was y, right? Y with a negative sign gives us the center. Clear? Okay. So I'll erase this part, keep the center part, which is center at -9 and 1. Now, find the equation of line L in the form ax plus by plus c equals to 0, where a, b, c are integers. But this line is tangent to the circle at a given point, right? So that means we have to find slope with that point, right? So what is given to us is something like this. We have a circle here, right? And a point -9, 1, and a line being tangent at a particular point, which is -5, 7. So let me draw a tangent here. Okay, so let me just, okay, imagine this is undo. Okay, we'll redo it, right? So again, let me draw a circle here. Let me draw it here. And on this circle, I'll draw a tangent. Let's say this is the tangent. And the point on the circle center is -9, 1. And the tangential point is -5, 7. Correct?
Yeah.
So from here, we can actually connect the radius, and we have, let's call this point as P, as given there, and let this point be C, right? C1, okay, C. So slope of CP, MCP is what? Y2 minus Y1, which is 7 minus 1, over -5 plus 9. And I mean, that gives you what? 6 over 4, right? Which is 3 over 2, right?
3 over 2, yeah.
So slope of tangent will be perpendicular to this, which is going to be -2 over 3. And therefore, the equation will be y minus the y value of the point, which is 7, equals to m, which is -2/3 over x minus the x value, which is -5. That makes it +5. We can cross multiply. 3 times y minus 7 equals to -2 times x plus 5. So we get 3y minus 21 equals to -2x minus 10. Bringing all the terms together, writing it in standard form, we get 2x plus 3y minus 21 plus 10 equals to 0, which is 2x plus 3y minus 11 equals to 0. So we got the line equation in the standard form, where the value of a is equal to 2, b is equals to 3, and c is equals to 11 with a negative sign. Amy, did you get the same answer?
Yes, I did.
Okay, so we have the equation of the line also. So part A is done for us. Let's look into second part of this question. Amy, can you please read this question?
Yeah, so a different circle C2 has equation x squared plus y squared minus 8x plus 12y plus k, which equals 0. Given that C2 lies entirely in the fourth quadrant, find the range of possible values for k.
Correct. So it is independent of the first question, as you can see, but they're saying that a different circle, C2, has a given equation, right? So we can again find the center of C2. So what is the center of C2? Let me use a different, okay, let's write it.
Minus 6.
X value, half of -8 is 4, right? So with negative sign, and -6 is the y value, correct? Now we have that. Can you find the radius directly, Amy, or?
Yeah.
Radius, yes. Radius.
So the
we
radius
don't know
equals...
the radius, right? We don't know the radius because the k value is not known to us. That is the thing. So it says a different circle C2 has this equation where k is a constant. Given that C2 lies entirely in the fourth quadrant, find the range of possible values of k. So basically, what they're saying is that now the circle is in fourth quadrant, correct? So the circle is somewhere here. Do you see that? Oh, sorry, fourth quadrant. I made it in the third quadrant. Wait. So circle is in this quadrant, the fourth quadrant, right? That is the fourth quadrant. So that clearly means that we have the center, which is at 4 minus 6, correct? So the maximum radius can be what? it has to be within the fourth quadrant, correct?
Mm.
So the x value is 4 units to the right, the y value is 6 units down. So the radius has to be less than 4, correct?
Mm.
So we can say r is less than 4, right? If it is totally in the fourth quadrant. And therefore, we can now find the value of k with this constraint, right?
So I just didn't get, wait, so the center point is 4 minus 6. So
Yes.
the radius has to be less than 4.
Correct. Because if it is more than 4, then it will go to quadrant 3, correct?
Okay, yeah.
That is why, correct?
Mm.
On the upper side, there is margin of 6. So 2 more units to go. So we are safe. We are only bounded on the left-hand side. So taking that, we have the maximum radius of 4 units. So that will define the value of k. Is that clear to you?
Right.
So if you add and subtract half of minus 8, which is 4 square, so we get minus 16 here, correct? And half of 12 is 6, and square of that is minus 36. The plus 36 goes into completing the squares, right? Therefore, I'm taking the negative terms, right? And plus the value of k. This is the part of the constant c, right? We are looking for r square. So this is, we'll have these terms on this side, correct? And let me write this as clearly, because we know the radius. We'll say x minus 4 whole square plus y plus 6 whole square, right? So we have this equation equals to 0. Is that clear to you? Correct?
Yeah.
Taking all these terms to the right hand side, we get 16 plus 36 minus k, and this is equal to how much? 6 and 6, 12 to 1.
52.
52k. Now, radius is square root of this term, right?
Yeah.
Radius r is square root of 52k. And we want that value to be less than 4. So square root of 52k is less than 4. Is this clear to you?
Yeah, because we set up the radius is less than 4.
So we'll square both sides. And so 52k is less than 4 square, which is 16, right? So k is less than 16 over 52. So this is the k value, which will be, so let's see, what is this? It has to be greater than 0, of course, correct? So 16 over 52 becomes the value of k.
All right. Okay.
Is that clear to you?
Mm-hmm.
Right. So this is one part. Now, because it could go, radius is always positive. We cannot have this. So how much do you get this decimal answer? Well, we could divide by 4 and write 4 over 13. That's fine.
0.3.
Correct. 0.3, yeah, or approximately 1/3, right? Slightly more than 1/3. So that becomes the value of k. So the range for k will be this much, correct?
Okay.
Okay. Next question, please.
Question 12.
Now,
question 12.
Can you please read the question?
Yeah. So the equation k plus 3x squared plus 6x plus k equals 5, where k is a constant, and it has two distinct real solutions for x.
Correct.
Part A, show that k satisfies k squared minus 2k minus 24.
Correct. So what is going to be your approach in this question?
So when I did it, I started doing the b squared minus 4ac being greater than 0, because we have two distinct solutions.
Yes. Correct.
So a would be like k plus 3.
So b in this particular case is 6, correct?
Yeah.
But actually, first you rewrite this equation, because 5 will come on the left side. So that could be a mistake which you did, right? Maybe. I'm not sure about it. So k plus 3x squared, let me rewrite, plus 6x plus k minus 5 equals to 0, correct?
Yep.
So b is 6 here. So I'll write 6 squared minus 4 times a is k plus 3, right?
Yeah.
And c is k minus
K
5.
minus 5.
And that should be greater than 0. So we need to solve this particular equation. Let's try to do it, okay? So 36 minus 4 times. So k, we'll just multiply this. K square minus 5k plus 3k minus 15 greater than 0. So we get 36 minus 4k square. And these two terms add up to minus 2k multiplied with 4 gives us 8k minus 15 times 4 is 60, and we get a positive sign minus minus. So we get that particular equation.
Wait, so
yes.
Do we have to multiply the 8k by the 4?
Where is 8k? No, this was minus 5k plus 3k. So we have minus 2k. So I multiplied minus 2k with minus 2, right? And I got this answer, correct? So next term, so basically combined, and then I multiplied with 2, right? And the next term minus and minus became positive 60, correct? Greater than 0, correct? Perfect. So we can write this as minus 4k squared plus 8k, and 36 plus this is 96 is greater than 0. Will satisfy, show that k satisfies this part. Okay. So we can factor out 4, right? Minus 4. So when you factor out minus 4, the sign will become less than. Is it okay? So we have k squared minus 2k
minus 24.
24 less than 0. Because when you divide by a negative number, then the inequality changes sign. So we have got k squared minus 2k minus 24 less than 0 as the part of our equation. Is that clear to you?
Yeah.
Less than 0 means it has 2 zeros. So we have to factor this. So minus 24, can you factor 2 terms?
So you get k minus 6 and k plus
6
4.
and 4, correct. So 6 and 4 can work for you. So we get k, bigger number.
Oh, minus 6 plus 4.
And k plus 4, correct. And that is your parabola. And you want to be less than 0.
Less than.
This parabola is minus 4 and 6, correct. So I'll just draw this. And this point here is minus 4. And this point there is 6. And we're looking for a value which is less than 0. So the value of k will be between minus 4 and 6. Is that clear to you?
Yeah.
So those, now, do they say k is integer? Where k is a constant, has two distinct real solutions, correct. So the value of k, which is a constant, is between minus 4 and 6. Is this clear?
Yes, yeah.
So the beauty is that we have done the inequality just by sketching a graph. Normally, what will you do is you'll make a table and then check your values at during each interval, right? So you will check between minus infinity to minus 4, between minus 4 to 6, and beyond 6, right? Greater than 6, correct? And get the same result. However, this method is more efficient. You can actually sketch it on the side and see where the parabola is below the x-axis, and that becomes your solution. Is that clear to you?
Right. Yes.
It can save a lot of time in a test, okay?
Very clear.
I did notice that in your marking scheme, this particular method is not shown, but I think you should try this method and take a risk. It is worth it, okay?
Definitely. Okay. 13a.
Okay.
So prove that for all positive values of a and b, 4a over b plus b over a is greater than or equal to 4.
So first part is prove that for all possible values of a and b, this thing is greater than 4. Okay, so the only way we could look into is, because we have say all positive values of a and b. So a and b both are positive, correct?
So greater than 0.
So you can actually common factor, and then you could say, you could rewrite this as 4 is cross multiplied. So AB We can multiply everything by, so multiply both sides by AB, right? Do you understand?
Mhm.
So in that case, the first term will be 4a square, right? Plus b square, correct? Greater than equal to 4ab. Is that clear to you?
Mhm.
Now you can bring 4ab to the left side. So you get 4a square plus b square minus 4ab is greater than equal to 0, correct?
Yeah.
Bring 4ab in the center. Purposely, I'm taking one more step here to show you that we'll just make this as a perfect square. Because when we say is always true, that means we should have a perfect square on the left-hand side, correct?
Yeah.
You can see this, that this is like 2a whole square, right? Minus 2 times 2a, right? Times b, right? That center term plus
Mhm.
b square. Is that clear? That means I could write this as 2a minus
2a
2
minus
whole
b.
square greater than equal to 0. So the left side is always true. Is it okay? Always
Mhm.
positive. So it is always true. Is that clear to you?
Yeah.
That is how, yeah.
I did that, but I only got 3 out of 4 because they said you need to put in the right order. So I had to start with that, the 2a minus b whole squared, and then I have to work backwards basically.
No, the way I think we have done in this particular is perfectly fine. So what is not the right order here?
Yeah, so I did that, but then I didn't get the last mark. They said that you need to take the 2a minus b whole squared greater than 0, put that first, and then work backwards basically.
So what I did is okay, right? So I wrote
It's
this.
all right. It's just you need to put the 2a minus b on the top and then factor that out and then go all the way back to the answer in the question. But I didn't understand why to do that.
No, you don't have to do. Once it is perfect square like this, now you can say, because on the left hand side, you can say left hand side
Squared.
is always positive.
Yeah.
So maybe that there you might not have written. I'm not sure about it. But since it is always positive, therefore it is greater than equal to 0, right?
Mm-hmm.
It is a non-negative because 2a can be equal to b, right? Is always non-negative. Let me write non-negative. Is it okay?
Yeah.
Because it could be 0. Because for 2a equals to b, it is 0, correct?
Yeah.
So here we have a lot of restrictions. We could say, yes, it could be. So this is fine. So I think they're very strict about it. So it's good to write the left-hand side is always non-negative, and therefore it is true for all values.
Okay.
Maybe communication mark somewhere they deducted. Okay,
Okay.
great. So now let's see part B.
Oh yeah, I just subbed in a as -1, b as 2.
Okay, and you got the counter example.
Yeah, I got -4
Right,
is greater than equal to 4, and it didn't work. So
correct, correct. So the idea here is, see, when we are multiplying both sides by AB, we could do it mainly because both are positive. You get the idea?
right. Yeah, if
But
one
if
was
they are
negative.
negative, we don't know whether the sign is this side or the other way. You get the
Right.
idea? And
Yeah,
therefore, that method will not apply.
I see.
So you could
Mhm.
not have done the first method if they had not given you that both are positive. Is that clear to
Yeah.
you?
Yeah.
That is very important. And of course, counterexample means that if we take away the condition of both being positive, in that case, the statement is wrong. And for a
Right.
wrong statement, counterexample is the right way to go about, right?
Yeah.
And they have given you, well, provide counterexample to prove. Perfect. Yes. Next question, please.
So yeah, final question. It's a bit of graphs. So a curve has equation y equals gx.
Mhm.
Given that gx is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x.
Okay. So basically, if I write this as ax cubed plus bx squared plus cx, they are saying that c is equal to a, right? Ax, right? Cx plus, let me say d now, okay? Okay, continue reading. This is your function g of x, correct? Yeah, continue
Yeah.
reading, please. Yeah.
So the curve with equation y equals gx passes through the origin.
Okay,
The curve with equation y equals gx has a stationary point at 2, 9.
okay.
Part A, find g of x.
Good. So there are only A, B, and D, three unknowns to be found, correct? There are only three unknowns left now, correct? So we need only three conditions. We know that the curve passes through origin. That means I could substitute 0 point here, right? So 0 for x will give me 0, right? Output is also.
Oh,
So when you plug this in, you get the value of D. So this
that's
implies
0.
that D equals to 0. Is it okay?
Yeah.
So basically now we can write g of x as equals to ax cubed
Plus
plus
bx
bx
squared
squared plus ax. Is that clear?
ax.
Now,
Yeah.
next part is the curve with this equation has a stationary point at 2, 9. That means the point 2, 9 is on the curve, right?
Yeah.
So we can plug 2 here and we should get 9 as an output. Putting 2 for x, 2 cube is 8. We get 8a plus 4b plus 2a. Is that clear? So
Yeah.
that means 9 is equal to 8 plus 2, 10a plus 4b. So we can call this as one of our equations.
Equation. Yeah.
Now, do you remember what is stationary point? So that is the part of calculus which has been introduced here, right? Yes.
Yeah. So, you know, when you differentiate,
Hmm.
you have a stationary point. So that's when the f of the derivative is 0.
So g dash x, g prime x, so the derivative of x is 0 at a stationary point, right? At the point which is given to us, which is 2, 9. This is what
Yeah.
they're trying to say. So let's find the derivative of this particular function. It is a simple polynomial for us, which is ax cubed plus bx squared plus ax. So it'll be 3 ax squared, correct?
Yeah. Plus
Plus
2
2bx
bx plus a.
plus a, right? That's correct. So that becomes the equation. We can now substitute
2, 9.
0. Yeah, 2 for the x value. So g prime of 2 is 0, right? So when you substitute 2 here, we get 2 squared is 4, 4 times 3 is 12, 12a, plus 2 times 2 is 4, 4b, plus a, right? So we get this. So 0 is equals to 12 plus 1, 13a, plus 4b. Is it okay?
Yeah.
So we get 4b equals to minus 13a, correct?
Yeah.
Call
Sub it
this
in.
as equation. We'll sub it in here, right? So 10 equals to 10a minus 13a, which is minus 3a. So a equals to minus 3, correct?
Yeah.
So when you plug in minus 3, you get 4b equals to minus 13 times minus 3, and b is equals to product of these two and divide by 4, right? 3
Yeah.
39. 39 over 4. Clear?
Yeah.
So we have our equation. So let me write down the equation right in the middle. A value is minus 3. So we got minus 3x cubed plus b is 39 over 4. Okay, so and then this is x squared, and the value of a is minus 3 minus 3x. So that becomes the function g of x. Is this clear to you?
I see. Yeah.
Right. So are the steps clear, Amy?
Yeah, very.
Can you please repeat the steps, because I did a lot of things like here and there.
Yeah. So when you read the question initially, it says g of x is a cubic expression. So the first thing to do is write the general expression like ax cubed plus bx squared plus ax plus d, which equals to gx. And then it tells you in one of the bullet points that the curve, the equation y equals gx passes through the origin. So we just substitute the point 0, 0 into the above equation of gx, and we get that d is 0. So we can just eliminate that from our equation. And then the next bullet point says the curve with equation y equals gx is a stationary point at 2, 9. So we just have to differentiate and know that the derivative of g dash x is equal to 0. So we had to derive that expression of g dash x, and by using the calculus rules, we got the formula of 3ax squared plus 2bx plus a, and then simply substituted the value of 2 as x, and then got two simultaneous equations, and then solved. But you didn't do like the the classic thing where you cancel out. I prefer your method of, because we already had 4b there, So you just made 4b as the
Yeah, yeah,
subject and subbed in. Yeah,
correct.
that's so much better. Yeah.
You have to work with your open eyes, right? See
Mhm.
what should be substituted where, right? So
Right.
for the benefit of some of the students, the derivative rule which we use was the power rule, correct? So if a function is a x to the power of n, the derivative is a n times x to the power of n minus 1, correct?
Right.
So that
Yeah.
is what we use to get our derivative.
Oh, so that was it.
Oh, is that
Well,
all?
yeah.
Okay, that's fine. So today, let's brush up with what you're doing at school so that you are perfectly fine with all that. Can you
Okay.
tell me which particular topic are you working with?
Um. So, do you think we could just do a quick recap of like modulus functions?
Oh, sure. Yeah.
Because we've just started it. So
Right.
my teacher wasn't in, so yeah, had to kind of just start by myself. But at least you gave me the backup beforehand, so I found it easier, just to get the gist of it.
Good. So you're doing modulus function. Let me give you a quick review on modulus function. Okay.
Yes, please.
We also
Oh,
call
sorry.
it.
Let me stop sharing.
I think it's okay. Can you see my screen?
Yes, I can.
Oh, very good. So modulus function, right? We also call it absolute value function. Basically, it means that the output of a modulus function is always positive. Is that okay? Non-negative, I should say, right?
Okay.
So the key here is that non-negative range. So if I have to sketch this particular function, it is kind of like this. Consider a straight line y equals to x, right? Consider a straight line y equals to x. As I said, the absolute value, so let me write absolute value of x here, right? So let me use a different ink, okay? Absolute value of x is positive. That means on the right hand side, it will be y equals to x as such, but on the left hand side, it gets reflected, right? So it becomes kind of like this. Do you see that?
V shape. Yeah.
So that becomes the absolute function. So basically, it is also defined as a piecewise function. So I'll say absolute value of x is equal to, when it is on the positive side, then it is just x when x is greater than equal to 0. However, it is negative value of x when x is less than 0. Is that clear to you?
Yeah.
Okay. So that is the absolute function. Domain has no restrictions at all. Range is greater than equal to 0, as you can see. And some important points which you should include here is that this point is a vertex. Sharp corner. It means tangent is not defined.
Oh yeah, I remember that image that you're drawing. Like you can draw the tangent at any point of that.
At origin, right? Do you understand?
Yeah.
That means derivative is not defined. Do you understand?
Yeah.
At origin. Now, this is very important since, in calculus part, when we work with this particular function, so there is a point where the derivative is not defined, correct? So let me jump to this derivative part without wasting much time here. Most of the time, you will never see this figure which I'm going to sketch now. Can you tell me what is the derivative of this particular function? How will you sketch the graph of that? Yes, Amy, tell me.
So the function is absolute value of x, and you want the derivative.
Yes.
Let
me write here. It'll be easy for you. It'll be easy for you. What is the derivative of x?
1.
When x is greater than equal to 0, what is the derivative of minus x?
Minus 1. Oh.
Great. And therefore, we can draw the derivative. So, but at 0, it is not defined. So, do you see that?
Oh.
Very beautiful curve. So, this is the derivative of absolute value of x, which students overlook. and they only realize it at the end of the mock test.
Right. Can I sketch that quickly?
You see that one? So
I fell into the trap.
yeah. So most of the questions start with a function. They will do something with the function, transformations or something, right? And then they move on to a calculus part using derivatives and some questions there. This is the question on calculus side of absolute function or modulus function. Is this point
Right.
clear?
Yes. Yeah.
And in many different ways, we are going to ask this question. I'll actually, once you take a copy of this, take a picture of this, I'll give you another function, which will be absolute value of a different function. And we'll try to sketch the graph of that function. Is that clear?
Yeah.
Okay. So I'm wiping off all this, okay?
Okay.
Okay, now, there you go. So we have this function, let's say f of x is equals to absolute value of x squared minus 1. I want you to sketch the derivative of this particular function, x squared minus 1, absolute value. Okay. Can you help me, please?
2x. Absolute value is 2x.
Okay. So you're defining this particular function first, and you're writing this as the positive value x squared minus 1 if x is what? Well, when x is positive, no, see this. This is your graph. Do you see that graph of x squared minus 1? We have gone 1 unit down. Is it okay? These intercepts are at plus and minus 1. And therefore, the graph remains same wherever it is above the x-axis. So it will be x squared minus 1 if x is less than minus 1 or x is greater than 1. Do you see that?
Right.
The absolute value function. I have not yet sketched the absolute value function. What I have sketched here is basically x squared minus 1. Let's wait.
I see.
Right.
Okay.
Now, the center portion, which is negative, has to come out, right? It has to become positive.
Oh, has
So
to
we'll
flip.
do negative of this. Do you understand?
Minus x squared minus
So that
1.
means I have to flip it, correct? So I'll flip it, use a different color. So this goes like this. So that is my absolute value. On this side, it remains same. Do you see that?
Yes, yeah.
So this is my absolute value of x squared minus 1. Is this clear to you?
Yeah.
Okay. So let me put power is going off. Okay. Battery, clear. Good. Do you see this absolute value of x squared minus 1? So now you understand the function. It is every time all positive, correct? My question now is, okay, I should not be writing this. This is the, now I want you to sketch the graph of the derivative. Can you write down the derivative equation, if that helps you?
So is it 2x?
Right.
And then
x
where x is less
minus
than
1,
minus
where x is greater than 1, and this is minus
2x.
When x is between minus 1 and
positive 1.
And positive 1, right? So this is between minus 1 and positive 1, correct? So we'll take equal to signs on the other side, okay, which we are keeping positive. Is that okay?
Yes, yeah.
So now we have covered everything. This point actually is included, right? Very much included. This circle is like closed circle, right? Now, the derivative, as you can see, is right there. Can you please sketch the derivative and check with me the answer? So in the center portion, it is minus 2x. Do you see that? In the center portion, how will you sketch this? Minus 2x means a line which will be going down. But if x is minus 1, if x is minus 1, then it is plus 1, right? So it will be from here to here. Do you see this? So this is minus 2x. Is this clear? Is this correct or wrong? Tell me. Center portion. Very tricky graph.
But are you allowed to go below the axis?
No, this is the derivative. Derivative could be negative or positive. Last time also we got negative 1, correct?
Yeah.
So minus 2x, and x values could be from minus 1 to plus 1. So if I write minus 1 here, minus 1 times minus 2 is plus 2, right?
2, and then minus 1
so
is 1.
This should be at 2. Is it okay? I should have made it steeper, right? This will be at 2. Is it okay?
Oh, yeah.
Yeah. So sorry. Minus, this is the graph of the derivative. Let me just write derivative of
minus 2x.
Minus 1 derivative, right? So this is derivative. The different scale.
How do you know whether to draw the line of 2x or minus 2x?
Well, here we have the derivative as a piecewise function. Do you see this piecewise function?
But you haven't drawn 2x.
No, minus x is between -1. It's a straight line. 2x is a straight line. Negative slope means going through the origin, right, with a slope of 2. And when x is -1, then be +2.
Yeah.
So we get this diagonal. Now we have to do the upper half.
Oh, yeah, that was my question.
That is your question, correct? So if it is -1, if I put it -1 here, I get -2, right?
-2.
Yeah, but the slope is positive. Do you see that?
Yeah.
So at this point, I do get -2, and slope, and further if you go, it is like this. Do you see this?
But if we sub in x as 1.
Okay, so that is on this side. If you put sub as x as 1, then it is +2, and it goes like this. Do you see that?
Yes, yeah.
You get the idea.
But so, you know, with that one that you drew, because the inequality is greater than or equal to, do you fill in the circle or no?
No, because at this particular point, it is not defined.
Oh, because they're like cusps.
So you will write only greater than equal. Is that clear to you?
So no equal to sign.
At this point, the derivative does not exist. So you'll have holes here. Do you understand? Very important graph. So one thing is these simple lines, they are very complicated.
Yeah.
Plus the holes everywhere, right? So those are discontinuity points, right? Jump discontinuity, we are right there. Very important test question on absolute function derivatives. Is that clear to you?
Yes, yeah.
Okay, great. So, okay, now let me share with you, some time is there, right? There is 10 minutes to go. Absolute function on a number line when we write solution of inequalities. Let me say solution of inequalities. Let us say we have an inequality which is x is between, let's say, -3 and +3, right? Very easy to write absolute function inequality. We say absolute value of x is less than 3. Is that clear to you? Less than equal to, correct?
Yeah.
So that really means on a number line, the solution is what? Is the solution is from -3 included, right? From +3. Is that okay? That is this solution. Is it okay?
Yeah.
So you can write a solution of an inequality on a number line with the help of this, or you could also say like this, right? -3 to 3. These are different ways, correct? Writing the same,
right, yeah.
including the
square brackets, yeah.
In absolute function. So I've shown you 4 different ways of writing the same inequality and showing it on a number line. Is that clear to you?
Yes, yeah.
Next question, which is the examination question. I will start with the number line, and you have to provide me with the absolute function inequality. Okay, the solution here, this point is -3. However, I move this point further to 5. Now tell me what should be the absolute function inequality to represent this, which is basically x is greater than -3 but is less than 5. You could also write this as -3, 5. These are open brackets, correct?
Yeah.
How will you write this as an absolute function inequality? That is my question, Anil.
So wait, when it was -3 and 3, you said the absolute value of x is less than 3. Correct. So in this case, would you just do absolute value of x +2?
No. So I'll tell you this strategy. It's a very important strategy. Make a note.
Okay.
It comes from the basic definition of absolute function. Absolute function represents distance. You know, displacement has a sign, but distance is always positive. You get the idea.
Right.
So think about like this. If I say absolute value of x is less than 3, it means within 3 kilometers. Do you understand? So you're right in the middle, and everything within 3 kilometers is what is implied when I say absolute value of x is less than 3, correct?
Yeah.
So the idea here is you have to come to the middle. Now, what is the center point of -3 and 5? To find the center, what will you do? First step, -3 plus 5 divided by 2, which is 2/2, which is 1. So you come to the center point, which is at 1, correct? This is first step. Is it okay?
Yeah.
Second step is, how far are you from the boundary? So find the boundary distance, right? Distance.
+4. No.
Distance, right? So distance is 4 units, correct?
Yeah.
Now, absolute function sits right there in the center and is saying that, well, you should be within 4 kilometers now. Is that okay? So what is the absolute function which is translated 1 unit to the right?
It would be absolute, so x minus 1.
And it has to be less than 4. So that becomes your answer. Does it make sense?
Oh.
That's how you're
Yes.
going to do it.
Right. Understood.
Very, very important question. Most of the questions or the examples in the book will have similar values on both the sides, and becomes very easy to write the function.
Oh, I see.
However, if it is like this as I have shown you, then it becomes extremely difficult to get the answer. If you don't know it, it's very difficult. But simple steps, get the center point and how far are you from those points is the absolute value inequality. Is this clear to you?
I see. Yes.
Last question for you. Last question of the day. Again, I'm making absolute function inequality, but this time I'm moving away. So I'm moving away from here to the left. Let's say this point is again -3. On the other side, let me go to 7. Now tell me, what could be the absolute function inequality to represent this solution on a number line? Which is
would it be
less than, yeah, tell me.
x less than 3, x greater than 7?
Yeah.
I don't know if you can do that whole midpoint thing. So minus 3 plus 7.
You have to do. Yeah.
Oh, okay.
-3 plus 7 divided by 2 is how much?
Minus, no, 4 divided by 2 is 2.
Yeah.
So
How
when you
far?
draw the thing, the distance between them is 5 units. So you'll do inequality of x minus 5. No, sorry, x minus 2. Yeah. Greater
than 5. You're moving away from that value, correct? So greater than 5 will now be the absolute function inequality representing the solution on a number line. Is that clear to you?
Oh, yeah.
Very important. So this is how you have to work with the absolute function. I'll recommend that you look into my playlist on absolute function. Just type in Anil Kumar absolute function playlist, and you get hundreds of examples to master. Okay.
I see.
And for your homework, this is again a challenging question for your homework. I'd like you to write absolute function equation or an inequality or whatever, which represents this solution, that this is everything but 5. Do you understand? Everything but 5. I want absolute function to represent this. Everything. X belongs to real numbers. X belongs to real numbers, but X is not equal to 5. I want you to write this as an absolute function inequality or equation or whatever you want, but use absolute function. Is that clear to you?
Okay. Yes.
Try this out.
All right. Will do.
So
thank you so much.
We'll end our class here, okay? So I hope you learned a bit today.
Yeah, I learned a lot. Thank you for that recap. Clearly, I'm a bit dusty on that, so I need to obviously do a review. But yeah, you touched upon the key points, so that was really important. So I'll keep that in mind, yeah, for the future.
Great.
All right.
Okay then, all the best.
Thank you so much.
Bye.
Bye.